Hello, AP Statistics students. Welcome to this edition of Free Response Practice. Today we're taking a look at 2019's exam number 2 that is about experiments and experimental design. Now this problem should actually look familiar because I think we did this first semester, but it's got a lot of good things in it, so I think it's good for us to take a look again. So let's see. Researchers are investigating the effectiveness of using a fungus to control the spread of an insect that destroys trees. The researchers will create 4 different concentrations of fungus mixtures: 0 milliliters per liter, 1.25, 2.5, 3.75. All right. An equal number of the insects will be placed into 20 individual containers. The group of insects in each container will be sprayed with one of the 4 mixtures. The researchers will record the number of insects that are still alive in each container 1 week after spraying. So, first thing, identify the treatments, experimental units, and the response variable. So, the treatments, I think, is the easy one. It is the 4 concentrations of fungus mixture. All right, I read the rubric here. You did have to somehow use a plural form of this. There's more than one you couldn't just say fungus mixture. It had to be plural. You had to show that there were 4 different levels of this treatment. There are 4 concentrations of fungus mixture. Even better if you put 0 milliliters per liter, 1.25 milliliters per liter, 2.5 milliliters per liter, and 3.75 milliliters per liter. But somehow you had to show that there were 4 different levels there. You could not just say fungus mixture. All right, the experimental unit's probably the harder one here, most definitely, because the tempting answer is to say the bugs. It's not the bugs, all right? I know, it's like, but we're spraying the bugs, Bolt. Well, yeah, but you are not randomly assigning treatment to individual bugs. You are not holding up each bug and saying, you get this one, and then the next one saying, you get this one. That's not what we're doing. What are we randomly assigning treatment to? The containers. All right. The containers are our experimental units because we're holding up each container and then randomly assigning a treatment to it. Each container is assigned treatment. So yeah, the experimental units, what are you assigning treatment to? Not just necessarily who you're spraying. The response variable, here you can also get into trouble. You might just be tempted to say, oh, if the bugs died or not. I don't think that's quite good enough, all right? What are we recording? Okay, it's right here. What are we recording? All right, the number of insects that are still alive after 1 week. That is our response variable. All right, does the experiment have a control group? Explain your answer. Hopefully this one's pretty obvious. Yes, it does have a control group because one of our levels doesn't have any fungus in it, right? This is fungus. We're using this is a concentration of fungus, and one of our sprays doesn't have any fungus. Zero milliliters per liter, and so has no fungus. All right, that is our baseline comparison. I don't think you need this sentence, but I'm going to put it in there just because I'm a teacher. This gives us a baseline of comparison. All right. That one's not too bad, I'm hoping. All right, letter C is really where things get difficult, I think. Definitely the hardest part of this question to get all the points. Describe how the treatments can be randomly assigned to the experimental units so that each treatment has the same number of units. So how can we randomly assign these 4 treatments so that the same number of treatments are out there? Okay, so first I'm going to give you a wrong answer. Here's a wrong answer. Tempting, I know, but it doesn't quite do it. For each container, randomly generate a number from 1 to 4. If you get a 1, use the 0 milliliter solution. If you get a 2, use the 1.25 milliliter solution, etc. Do this for all 20 containers. Think about that. Pause the video if you need to. What's wrong with that? Why does that not work? Did you get it? It's because we're doing that random from 1 to 4 for each treatment, we might not get the same number of each treatment, okay? And they want to make sure that each treatment has the same number of units. If we're randomly generating from 1 to 4, it's possible we'll never get a 4, or we'll never get a 1. If we never get a 1, we would never have our control group, our placebo. That it's not likely, but it's possible, and it's actually very likely they won't be equally spaced out. So we have to come up with a method to make sure that the treatments are randomly assigned, and yet, let's see, we got 20 containers, right? And we got 4 treatments, so we should have 5 of each. How can we make sure that we have 5 of each? So this is the easiest way I think I can come up with, all right? So first, label each container, label the containers from 1 to 20. Okay, label your containers. Then, actually not necessary in this, I'm sorry. It's not a bad idea, but, all right, take 20 pieces of paper. All right. On 5 slips of paper, write treatment 1. 0 milliliters per liter. On another 5, put treatment 2, which was what, 1.25? I forget. 1.25 milliliters per liter. And so on for all the slips of paper and each treatment. And just to clarify, each treatment should have 5 slips of paper now. Okay, just to make sure they know that I know there's 5 of each. Okay, put these in a container and mix them up. That actually is important. The mix up was in the rubric. You had to randomly use these pieces of paper somehow. So the mix them up was important. For each container, all right, randomly pick a slip of paper and administer that treatment to it. I think that's the easiest way to fulfill this, all right? I know I'm going to get 5 containers for each treatment now because there's 5 slips of paper for each treatment. It's still random because I'm randomly picking them out of the hat or the container for each of these containers. So I think that's the easiest. Slips of paper are not a bad idea. Another option, you could also use a random number generator. All right, it is possible to do this correctly with a random number generator. So here you number the containers from 1 to 20. use a random number generator to generate 15 unique numbers from 1 to 20. So the word unique there is important. You have to ignore the duplicates, which is a little annoying if you're using a random number generator because you will get duplicates, especially if you need 15 unique ones out of 20. That can be kind of hard to do, but it's possible. It takes a while. The first 5 random numbers you get and the corresponding container, that's why we had to number the containers, will get treatment 1. Then the second 5 will get treatment 2, the next 5 will get treatment 3, and then the 5 unpicked containers will get treatment 4. So that's a way you could do this one with a random number generator. I think the slips of paper is a bit more intuitive from the start. With the random number generator, you definitely have to say something about ignoring duplicates, getting unique numbers, and you can't do from 1 to 4. You had to do either 15 or you could supposedly do 20. That would take a long time, but you don't actually have to do this. You just have to describe it. All right, hopefully that makes some sense. Those are all really important things about experiments.